we stopped last time. We go a little bit further than this, but reminder, this is the two questions I mentioned last time is if we have this question here, if we have this question here in terms that, no, not this one. In terms of if this question, they give you specifically the range, not the range, but the width, and specifically where to start, then we just using what information they give us, which is, again, they tell us how big is each class and where to start for each class, which is we start from 55, and then every time we jump, we just add 5 and so on and so forth, right? And again, to find this item here, which is, again, to find this item, we have to go in our raw data and looking for that information. The difference between this particular problem and the problem that I went over, the last problem we went over last time, is this one here, they don't give us specifically what is the width of the problem, right? They don't give us like, oh, I want 6 data in my class, right? We don't know the width, right? They ask you, well, not this one, sorry. This problem that we stop is for particularly this problem for A, they give us the data, but they don't tell us what the class width, right? They ask us, well, we need to come up with the class width that include 11 class. And last time, this is what we did was, again, for this author, like I mentioned, the first thing is we need to take the highest, looking for the highest data. In this case, our highest data is 52. We take 52 and divide it by the total number of class we want. And like I mentioned, this thing last time is whatever your decimal is, because they ask us for the number of something, the number of class, we need to go up to the whole number. So even if this were to be 4.3, we still have to go up to 5, right? So coincidentally, the class width here is 5, similar to the previous problem. It's not always 5, it depends on what we have, okay? So if for instance, if they want to have a 10 classes, which is 52 divided by 10 will give you 5.2, then we have to go up to 6, okay? So again, it does not hold the same routing rule like before, okay? So the other thing that we have is if they don't give us the starting point, for this author, he wants to make it easy in terms that look at your data, look at your lowest data, and then just go a little bit less in terms of a multiple of 5 or a multiple of 10, right? So in terms of this thing here, our lowest data is 3, then for him, he just go to 0. For instance, if your data is like 12, then go down to 10. So they basically just go down to a multiple of 5, make it a little bit easier to go up. Okay, so looking at this thing here, this is what we have, which is, again, for instance, our lowest data, which is, again, look at this thing here, we want to start at 0, and every time we jump, we have to add our class width, which is 5. Okay, and now this is one thing we have, or one thing that you guys need to pay attention in your Connect Math. If you do this problem on Connect Math over the weekend, you probably have a little bit of frustration on it, is what is the upper limit, right? What is the upper limit? Why is this upper limit is 4 and not 4.9, right? The reason is, first you have to ask yourself is my data discrete versus continuous, right? If your data is discrete, then you have to go to the whole number. Okay, remember discrete is the counting number 0, 1, 2, 3, 4, 5, right? And again, looking at this thing here, you say, wait a minute, Mr. Tran, this is hour, and if relate to Tom, it would be continuous, right? But true, but the reason why this thing here is discrete is because they ask you that the number of hour, right? The number of hour is either 1 hour, 2 hour, 3 hour, because we're looking for the actual number of hour, not the time interval itself. So therefore, because of the number of hour, that's why it's a discrete item rather than the continuous item. Everybody see that? Okay. So again, if it's the discrete item, your endpoint, you will go close to 5, which is the next whole number below 5. right? The next number below 10 will be 9, and so on and so forth. So again, I think last time I did not explain the difference between that, and I say, well, if it's an hour, and then we come to here, you say, wait, why is not 4.9 rather than 4, right? Because they ask us for the number of hours. That's why, because it's a discrete item. That's why we have to start at 4. Okay, so that's the one thing on Connect Math you have to pay attention is it a discrete data, which is discrete is counting number, or is it a continuous data? If it's a continuous data, then you want to go to the decimal. The other thing is, if your data have a decimal, then you go to a decimal. If your data does not have a decimal, then again, is either discrete or continuous in terms of that. Okay. So once we have this thing here to come up with our frequency, which is now we just go and ask ourselves, in my data, how many of my data is between 0 and 4, which is, again, you go in and you count your raw data, which is you have 5, I think, right? You have 5, and then you go in there and you count the rest, which is, again, to test or to see if you have the right item or the right frequency. You just add this thing here. If it's equal to 40, most likely you have enough data, right? And again, the next thing they will ask you is, how do we find a relative frequency, right? How do we find the relative frequency, which is the relative frequency is, reminder, is we take each of your frequency and divide by the total of 40. We have 40 subscriber, right? Which is you take 5 divided by 40, 6 divided by 40, and so on and so forth. And you add, if you add the relative frequency, it has to be equal to 1. And again, this is where we stop in terms that to construct a histogram, reminder, your frequency, very important, your frequency will always be on your vertical axis, and your horizontal axis is the data, which is in this case, the number of hours. And all you need to do is list your lower limit, and then you go and ask yourself again, from 0 to 4, how many frequency do I have? Which is, again, I think Connect Math is not very tedious in terms that it has to be exactly at 5. You know, if you have it like this, they guesstimately, they will give you a correct answer. So again, we just go in and fill in our frequency, right? The 0 will have 0, 0 here. And if they were to ask you to find a relative histogram, instead of a frequency, you just put your percentage or your decimal, right? The highest decimal we have is 0.225, so I just go by 0.25, which is, again, from 0 to 0.05, 0.05 to 0.1, 0.1 to 0.15, 0.15 to 0.20, and so on. Every time I jump by 0.05. Okay, so again, that's what they have, and I think on Connect Math they put the divider for you. I don't think you have to fill in your frequency. So again, the other question, I think my previous section they asked, is this a skew to the left or skew to the right? Reminder, if you look at the graph, it's basically the opposite of what you're looking at, right? Or it's basically the point of view the graph looking at you. So this thing here is basically skewed to the right. Okay, so again, the graph looking at you, this is the right of the graph. It's on your left, but it's on the right of the graph. So this is skewed to the right. Okay, so again, this is where I think this is where we stop in the sense of last Thursday material. Question: with the frequency distribution table, relative frequency or histogram? So now, if you don't have question, let's take a look at the next 2 items we have, or 3 items we have, which is the stem and lip plot. The stem and lip plot, probably the one thing that you will have a frustration on your homework over the weekend, right? The one thing is the stem and lip plot on your Connect Math, they need to be in specific order. But what is the stem and lip plot? So this is what we have is the stem and lip plot is basically the most right digit, or as you will see, the smallest digit is your leaf. and whatever the remaining digit will be your stem, right? So again, looking at this thing here, if we have 14.8, what is the smallest digit? The smallest digit is the 10th, which is the 8 right here, right? The number 8, but the position is at the 10th place, right? So looking at this thing here, this 8, number 8 is at the 10th place, which is the smallest item, that's your leaf, and the 14 will be a stem. Same thing go 2,739, the 9, which is at the 1 position, the 1 position here, that's the smallest data, or not smallest data, smallest value or digit. That would be your leaf. Everything else will be your stem. Okay, so this is what we have is, for instance, if I give you this raw data, if I have this raw data, let's say that this is, I think 35, 918, 25, let's say this is my 25 score. Oh, that's very low score. Whatever this data is, doesn't matter, right? Let's say if I ask you to construct the stem and leaf plot. And now looking at this thing here, if you glance through this thing here, you can see that the smallest data is 11, and probably the highest data is 58, right? We do not exceed 50, so everybody see that this thing here is in the 10, the 20, the 30, the 40, and the 50 range, right? We don't have any 60 data. So looking at this thing here, if you glance through this thing here, you ask yourself, well, what will be my stem? My stem will be, again, from, if it's in the 10, then it's 1. If it's in the 20, it's 2. It's in the 30, it's a 3. If it's in the 40, it's a 4. If it's in the 50, it's a 5, right? If we have 60, we have a 6 here, but in this case, my data don't have any 60. And how do you construct your stem and leaf plot? All you do is you go to each individual data, which is the first data I have at 57. All you do is you go to the 5 and you write a 7. The next data is 20, you go to the 2, you write a 0. The next data is 27, you go to the 2, you write a 7. Next data is 16, you go to the 1, you write a 6. Vice versa, 11, you go to the 1, you write a 1. And 12, you go to the 1, you write a 2. So again, each of this number is one particular data. You read as in 16, 11, 12, 20, 27, 57. And again, everybody see where I have the first 6 data that I have here. I have 3, 4, 5, 6. I have 6 data, and where those 6 numbers come from. Basically, you go into your individual data and you go, if it's the next number I have is 29, I go to the 2, I write a 9. The next number I have is 39, I go to the 3, I go and write a 9. And the next number I have is 45, I go to 4 and write a 5. Which is, everybody see, I finished my first row. This is my first row of data. This is, once I have it, I go in and I write the right number, okay? And again, all you do is, we go to the next row, which is 52. We go to 5, write a 2, 58, 15, 46, 27, 22, 21, 15 again, and 50. Everybody see that I'm done with my second row. And again, we go to the third row, which is 16, 45, 20, 55, 12, 33, and 30. And I'm done, which is, this is all we have. So one thing about Connect Math is they want you, or you have to, not that they want, you need to put your leaf in order. If you type it this way, Connect Math will probably say your answer is wrong. And you don't know why it's wrong. It's probably because it's not in order. It has to be from smallest to largest, so that in that way you can find what is your next item, is what is your mole, right? What is the item appear the most, or something like that. But again, this is what we have. But so what is the unique thing about the stem and leaf plot? Well, the unique thing about stem and leaf plot is, ladies and gentlemen, is basically it's the same as your histogram, turn it sideways. So if you take the stem and leaf plot, I just take this thing here and I flip it this way, upside down, right, or right side up. If I flip this way, everybody see that I have a ball here, a ball here, a ball here, a ball here, a ball here. So basically, this is my histogram, right? And again, the good thing about this histogram or this stem and leaf plot is now you know exactly what the data is, right? If I have a histogram, if I only have a board, and I ask you, well, how many data between 10 and 20? You say, well, there are 7 data between 10 and 20. But the histogram does not show you the actual data. The stem and leaf plot does, right? We know exactly 7 data in there, and we know exactly what data we have, right? We know that we don't have any 19, any 18, any 14, right? We know that we have 111, 112. We don't have any 13, right? 212, sorry. No 13, no 14, 215, and 216. So the stem and leaf plot is still give you that range, right? They give you that class between 10 and 20, 20, 30, 30 to 40, 40 to 50, and 50 to 60. But now we know exactly the actual data in there. And that's the unique thing about the stem and leaf plot, okay? The other thing about stem and leaf plot, before you guys ask question, or this is what we have is, the other thing about stem and leaf plot is on your Connect mat, they ask you to construct the back-to-back stem and leaf plot. So to compare 2 different data, right? In this case, I want to compare the average for English class versus the average for history class, right? So looking at this thing here, to create this stem and leaf plot, the first thing is the middle item is your stem, okay? So the middle item right here, this middle item is your stem. If you look at this thing here, again, your stem will be the smallest data. This one is nice for you guys. They put in order, which is 40 is the smallest data and 100 is probably the largest data. That's why we start at 4 and not at 1, 2, or 3, because we don't have any data of the 1, the 10, the 20, and 30. We have our data in 40 up to 100. And again, my data is a little bit reverse, which is my history is on the left-hand side and my English is on the right-hand side. So one thing about Connect Mat when you construct the stem and leaf plot is this, ladies and gentlemen, you have to put them in order. And if the item on your left, you have to set it up in terms of from the smallest to the largest that way, okay? From the smallest in the middle to the largest outside. And vice versa on the right-hand side, from the smallest to the largest that way. So again, in the middle will be your small data and you going outward, okay? So again, my history, as you can see, my history, I have 59, 61, 67. So again, this thing here, the data is in order, 71, 71, 73. That's what I have. 80, 82, 82, 83, 85, 88, which is, again, those are my data for my history class. And this is the rest of the data, right? So again, that's the tedious part on Connect Mat for back-to-back stem and leaf plot. You have to put your leaf, put your stem in the middle and your leaf on both sides, and on both sides, on the left-hand side, from smallest in the center to the largest on the outside, and vice versa, the smallest on the center and the largest to the right-hand side. So basically you go outward, okay? I think I have a student send me a question over weekend about this item on your homework, and we was not able to cover it last time. So question with this stem and leaf plot here, on how to construct the stem and leaf plot. All right, if you don't have question, let's take a look at the last 2 items, which is the dot plot. The dot plot, the dot plot is just like the name. The only thing you do is you just go into your data and put a dot into it. For every data you have, you just put a dot on it, which is, again, look at this thing here. They say consider the number of children that each of the president have during their presidency, right? Which is now looking at this thing here, which is my data from the smallest data I have is 0 child, and the highest data I have is 15 children, right? Which is, again, instead of list individually, we go by 2, right? This is the number of children they have, and basically you go in and again, you just basically, if you have a 0, you put 1 dot. If you have another 0, put another dot. If you have another 0, put a dot. Which is, again, is similar to your histogram. It's a dot plot, right? You plot a dot in, right? So again, basically you go in and just put a dot, and again, the most dot, that's the most frequency, which is a lot of presidents have two children, right? And you can count how many dots those or how many presidents have two children and so on and so forth. Okay, so that plot is not, and again on Connect Math, I don't think they make it any difficult in that and then this, right? You just go in and just select a dot and put it in there. The next item or the last item in chapter 2 we have is the time series plot. The time series plot, just like the name, is have to do something with the time. So you either graph them daily, meaning each day or each month or each hour, or in this case, each years, right? So again, it's anything that deal with time in terms of your item, then you have it. And the unique thing about this thing here is your time will always be your horizontal line. And whatever your data is will be your vertical line. So looking at this thing here, they ask you, consider this data of your Dow Jones average between 2000 all the way to 2012. So we know that 2000, we have the Dow Jones average is here, 2001, 2000, and so forth up to 2012. So after 12 years, we can see that the increase of almost $3,000 in terms of the Dow Jones average, right? So now to do this thing here, this is all we need to do is, again, your timeline, your time will always be here, which is in this case is in years. If it's in month, you put January, February, so on and so forth. If it's in hour, you just put your hour, right? And then your item, which is your data, will be on here. So if you did this over the weekend, or if you do this later on today, one thing about Connect Math about time series plot is they're very tedious in terms that you have to select the interval you want to point in, which is you have to select from 2000 to 2001. So on the bottom, like you have to select that item, and then you just basically click the dot, estimate between 10,000 to 12,000. They don't have to be precise. It's just guesstimate or estimate, but you have to click on this dot and then go to the next one, click this dot, so they draw the line for you. And you can only draw one interval at a time. And when you do it, you have to click from left to right, from left to right, from left to right. And then again, the next one, you have to go down and select the interval between 2001 and 2002. And then you click on 2001, go to 2002 and click another point. So they draw a line, and same thing, you click this and you click this point. Pretty much you have to work from left to right. If you click this and go on backward, if you click to the right and go to the left, they will tell you it's wrong. The syntax, the Connect Math syntax do not recognize from the right go to the left. It is have to be very precise in terms that you have to click on the left item, go to the right item, left item, go to the right. And again, your dot have to be overlap. This click here, they draw you, you click here, and same thing and so forth, so on. Okay, and again, the time series is basically tell you again when do we have an increase and when do we have a decrease. As you can see, 2007 to 2008, we have a big dip, right? We have again, we have a small dip here, and then slowly increase, and boom, we have a big dip, 2008, and then slowly going up. Okay, so again, that's what the time series is basically over time. What does your item do, right? Is it increase or decrease? Okay, so try to see if you can do the time series item on Connect Math. It's not hard. It's just Connect Math sometimes make it a little bit harder in that sense. Question here, question with the dot plot, stem and leaf plot, or in this case, the time series plot. All right. If you don't have question, 2.4, we will not really skip, but 2.4 is not that much of information. It's basically tell you that sometimes the graph can be misleading. It's basically tell you that sometimes your graph will mislead you in terms that if you have a figure that bigger than it is or something in that nature. It's basically tell you that sometimes the graph will mislead